We have discussed a processor with a single bus in our previous lecture, and we also saw how the instruction is fetched from the memory and put in the instruction register. So we have discussed the control sequence of how the instruction will be brought to the instruction register, and you can check my previous lecture to see that how these 3 clock cycles will be used to fetch that instruction. Now, after fetch comes the decode stage and the execute stage. So this instruction will be sent to the decoder. The decoder will check what is the operation that is to be performed, and based on that operation, appropriate control signals will be generated. So they can be sent to the external devices as well as the internal devices of the processor. Also, in the decode stage, the source operands will be read. So let's consider this data transfer instruction move R3 R1. So we are assuming that this is the destination. So this means that the contents of R1 have to be moved to register R3. Now for this, we know that the control signal for R1 has to be enabled. That means R1 out signal has to be set. This will allow the contents of R1 to be put onto this internal bus. Once the contents of R1 are available on this bus, we have to enable R3 in. So R3 in will allow the contents of the bus to go in register R3 over here. And this is the end of this set of instructions or micro instructions for this instruction move R3 R1. So this set of control signals which are being generated are 3 cycles for the fetch and 1 for the execution part. Now let's check how this instruction add R3 R1 R5 will be executed. So here R1 has to be added to R5 and the result has to be put in register R3. So as we have seen in our previous lecture, 3 clock cycles will be used for the fetch of the instruction. At the end of these 3 clock cycles, the instruction is available in this instruction register. So this instruction add R3, R1, R5 is available here in the binary format. So now the decoder will decode the instruction. It knows that this is an add instruction. Also the source operands are R1 and R5. So these will be read. So R1 out will allow the contents of R1 to come onto this bus. Now we want to add the contents of R1 with R5 contents. But we cannot put the contents of R5 onto the bus in the same clock cycle because we are having a single bus, and we know that in any given clock cycle only one unit can put its contents on the bus. So in the meantime, what we can do is that we will put these R1 contents into a temporary register Y. So R1 we have taken out and we have put the contents in Y. So in the next clock cycle, we can take out the contents of R5. So now R1 contents are present in Y, and now we have output R5 contents in clock cycle 5. So R5 contents are present onto the bus. Now these contents are available at the input port of ALU. On the second port, we can do a select Y so that the contents of Y can come through the multiplexer into the other port. So now at both the ports of the ALU, R5 is also available, R1 is also available by doing a select Y. The decoder will also generate a control signal over here. The control unit will generate this add control signal. R1 and R5 contents will be added, and now we have to put the result in Z. So Z in control signal will be set. Again, Z cannot output on this bus in the same clock cycle because R5 had outputted. So in the next clock cycle, Z will put its contents onto the internal bus. So R1 plus R5 is now present on the bus here, and then we will enable R3 in because R3 is the destination, and from the bus the contents, that means R1 plus R5, the result will go in R3 in. So this is the end of the control sequence. We will do the memory related instructions, load and store, using a single bus in our next lecture.